People will not join. So all of you keep reading. What is our today's concept? Normal force. Or we can, normal reaction or normal force. Now we all know, for example, if you take any kind of body, for example, I have taken a weight or some of the object who is having some mass. Now, some force, if I place it on the table, let me take, there is a table I have taken. So I have placed it on the table. I have placed it on the what? Everybody? Table. Okay. Now, so this weight will exert some force on the table. What is that force equals to? Anybody can tell? That is what we studied yesterday's class. Yeah. So this object is exerting some force on this table. That is what? Because of gravity. So that is what we used to call as, which is equals to what? Weight is equals to, respond, mass into gravity. Right? All of you agree with me? Yes or no? All of you?
Yes, sir.
So the force acting on the block is the force due to the what, guys? Due to the force, due to the something. What is that called as? The force acting on the block due to the gravity. So which is equals to what? Which is equals to weight of the block. Am I right? All of you? So if you want, you can write the statement also. So we all knows that the force acting on the block, okay, is the force due to the what, guys? Everybody? Force due to the gravity. So force due to the gravity, which is equals to what? We all people knows. Force due to gravity, which is equals to what? Weight of the block. Am I right? So weight of the block, which is equals to how much? Mass into acceleration due to gravity. So that is what? mg. Is it okay, guys? All of you? Yes, please. Now, if I take this one, always if you notice it, this force will act always vertically what direction? Everybody. This force is acting always vertically what direction? Fastly respond.
Downwards.
This force always will act vertically what direction? Everybody? It will act always vertically downward direction. So that is what I can say. mg is always acting vertically downward direction. Since the block is at, now the block is in state of rest or state of motion? All of you? State of rest. Okay. So the net force acting on the block must be is what? When the body is zero, when we can say body is in state of rest, net force is equals to what? Please respond.
Zero.
Yes. When we can say the body is in state of rest, when net force must be equals to what, guys?
Zero.
Means there must be a force which is acting vertically upward direction. Am I right, Mari? If not, this body should fall downwards. Am I right?
Yes, sir.
All of you? So there is a force which is acting vertically upward direction. So that is why the body is in state of rest. Am I right or wrong? Everybody agree with me or not? Yes.
Sir.
So there is a force which is acting vertically upward direction. That is why the body is not moving downwards.
Sir,
If
without
there is
any external force?
Yes, Mari. If the body is in state of rest, means in the sense of what? The net force is equals to zero. Am I right or wrong?
Yes, sir.
Means what does it mean? That there should be a force which is acting vertically upward direction and it should be equals to the mg. Then only the net force will become zero. Am I right or wrong?
Yes, sir.
Yes. So that is what
Sir,
the force...
I'm asking that
Yeah.
the object which is applying force downwards having no, sir.
Yeah.
That you are saying as mg, which is weight.
Now listen, Mari. I will explain. All of you listen. So suppose we all studied before. Suppose if you want to say, if this body is in state of rest, means in the sense of I am applying one force called as F1 and I am applying another force called as F2, so that this body is said to be in rest, means in the sense of what? F1 minus F2 is equals to 0. That is what? F net is equals to 0. Am I right, everybody? Clear?
Sir.
Net resultant force is 0, so that I can say that body is said to be in state of rest. Am I right or wrong?
Yes, sir.
Now, instead of side and side, I am taking up and down. So I know that there is a force which is acting downward direction, which is equals to what? mg.
mg.
And If this body is said to be in rest means there is a force which is acting upward direction and that must be equals to mg. Am I right or wrong? There is another force which is
Yes,
acting
sir.
in upward direction that must be equals to also what? Mg. Then if I subtract it, mg minus mg, what is the net resultant force? F net is equals to 0. Understand, Abhirami? Clear? Now, everybody. Understand?
Yes, sir.
Yes,
Yes,
that
sir.
is what.
Sir,
So, yes, Mari, ask me.
the upward force has without any external force, no, sir. There's no external force applied on the upward force, no, sir.
It's not that, Mari. No external force is acting, of course, but there is a force, weight of the body is acting downward direction. Means then there is a definitely the surface will exert the force in upward direction, which is equals to weight of the object. You
Yes,
understand?
sir.
That is what. So all of you observe very carefully. Now, here two surfaces are contact. What is the two surfaces are contact? One is object, block. Another one is what? Everybody, table. Is it clear, everybody? Now, we all know Newton's third law. We studied that. What is Newton's third law? Respond. Newton's third law. Every action is equals to what?
Equal and
Reaction.
opposite
Equal
reaction.
Opposite reaction.
Now, if I take this is the table, all of you observe, and this is the block. Now, block is exerting a force on table is equals to a weight, which is equals to mg. Then table also will exert the same amount of force on the block. Am I right or wrong? That is only we used to call as normal force. Do you all understanding, everybody? That is the reason the block is said to be in state of rest. Clear?
Sir.
If the block is exerting mg force on the table, then table also will exert same amount of force on the block, but in opposite direction. Am I right or wrong?
Yes.
What respond, everybody? That is what
Yes,
we
sir.
called as normal, or we used to called as, according to Newton's third law, that normal only we used to called as what? Everybody. Yes, please. Normal we used to called as what? Reaction. We used to call it as reaction. So this reaction is shown by what? Exerted by the table on the block, and it will act perpendicularly downward direction or perpendicularly upward direction. Upward direction. That is only we used to call it as R. R means what? Anybody can guess? R means reaction. Or we can say normal force. So from this you can say normal force always act opposite to the weight. Is it clear, everybody? All of you? If the weight of the object is acting downward direction, then normal reaction is acting upward direction. So from that, can you tell me R is equals to also how much? R is equals to body is said to be in rest. R is equals to what? Normal reaction is equals to mass into acceleration due to gravity. Is it okay, Mari? Understand now? Lingesh, Kishore, everybody? These both are equal. Clear? Nobody is saying.
Yes, sir.
Yes?
Yes, sir.
That is
Yes, sir.
Understand, Agalya? Any doubt, Agalya? Okay. So remember, the weight exerted by the block on the table is mg. Then block is exerting the same equal amount of force on the, bench is exerting the same equal amount of force on the block in opposite direction. That is what we used to call as normal, or we used to call as reaction. Is it okay, guys? Everybody understood or not? Yes. So R is equals to how much? Body is said to be in rest. R is equals to what? Mg. So that F net is equals to what? F net is equals to net resultant force equals to how much? Zero.
Zero.
That is what you have to remember. So please write the formula, definition. Normal force can be defined as Lingesh, are you there? Defined as the force experienced by a body. Gokul Raj, the force experienced by a body in a direction, how? Perpendicularly upward or downward? Yes,
Upward.
perpendicular to the surface, when it pressed against the surface. Pressed. When it is pressed against the surface. Against that surface.
So
Is
that
it
is
okay?
upwards, sir.
Yes, Mari. See, the block is pressing towards to the bench. So that bench will apply force in the upward direction. That upward equal direction, equal amount of force to the weight. That is what is only called as normal reaction. Is it okay, everybody? Understand, Amma? All of you?
Yes, sir.
Everyone respond. Clear?
Yes, sir.
Yeah. So this is what you have to remember it. Any doubt, anyone can ask me. Understand, Alfin, Rasini, Darshan? Okay? Yes. Yeah, this is for normal. So now bench is actually plane. So that object is also a plane. That's fine. It is very simple. Now there is a complication. So let us see that. How we can make normal reaction on a body placed on an inclined surface. Now I taught you, if it is a normal surface, if I place the object, so the weight of the object is always acting downward direction. Normal is acting upward direction, perpendicular. Always normal is perpendicularly to the weight. So that normal is equals to normal. I can represent with R also or N also. Please don't get confused. Both are same. Is it okay, guys? All of you? Yes?
Yes,
If you
sir.
are confusing. So R is equals to mg. I got it. If it is a plane surface. Now, our next concept is, please be very careful. If any small doubt, please ask me. Normal reaction on a body, placed on an inclined surface. So how many of you know slidings theriyuma?
Yes, sir.
All of you. So in this situation, what about the normal? So be very careful. I'll draw the surface and I will explain you. So any small doubt also you ask me, but here you have to use the trigonometry. Okay, Mari, now itself I'm saying, but you should learn the trigonometry. Okay. I will help
Yes, sir.
you, but you should learn it. So let me take it now, all of you. Yeah. So there is an inclined surface I am taking. All of you observe. This is what is my inclined surface. Okay, guys. So even I can avoid this. Let me draw. Generally, it is. So that is good for us. It is balanced, Amma. So since the forces are equal, it is balanced force. That is why it is body is said to be in rest. Understand, Saulila?
Yes, sir.
Otherwise, the body will start moving. Okay.
Okay, sir.
Clear? Everybody?
Yes, sir.
Yeah. So now let me take, there is an inclined surface. All of you observe. I will make it. So inclined surfaces means the surface angle will be theta. Am I right, guys? The angle between them, angle also will always will represent with the what?
Theta.
Theta. Okay. So please remember that. Okay. Now there is a block. So I'll put it. I'll put it and see, this much struggle is only to make you understand more easily, so that you wherever you go in future, so you should not struggle for the studies. That is what is things. So this is what is a block, is inclined surface. So inclined surface means you can see either the block is in state of rest or the block will start sliding downwards. Am I right? All of you? Yeah, it may
Yes, sir.
be. Of course, the angle is not much required. For example, see, you all put your hand parallel to your bench. Are you all sitting with the help of bench? Am I right? Everybody? Yes? So now put your pen on your hand. Is the pen will roll? No. You can keep on rising inclination so that your pen will start falling downwards. Am I right? Verify it, everybody.
Yes, sir.
Yes? So that don't think that this block will sliding. The theta will changes only, the block will start sliding unless it will be in state of rest. Am I right or wrong? Yes or no? Everybody respond, Ra.
Yes, sir.
Yes. So
Yes.
now first one, the weight of the object always act what direction? Everybody. Weight of the object always will act what
Forward.
direction? Fastly. It is an
Downward.
inclined surface.
Downward.
Weight of the object is always act what direction? Fastly, everyone.
Downward.
Downward direction. So that is what W is equals to. Capital W is equals to what? Fastly respond, which is equals to mg. Okay, guys. Now, so we all knows that always normal reaction will act in what direction? Perpendicularly
Upward
to the
direction.
surface.
Perpendicular.
Perpendicularly to the surface. Now, perpendicularly to the surface means all of you observe from this point. Do you think like this or it will exert like this direction? Perpendicularly to the surface. So what is the direction? This is the direction. Am I right, guys? All of you? Yes. It is an inclined
Yes,
surface. Understand, Mari? Lingesh? So it is an
So
inclined.
perpendicular means can you please move it aside, sir?
Yes. Which one?
Towards the right.
Which one, Ra?
So that arrow, perpendicular arrow.
Yeah, this is what the arrow. Okay. So that is what normal. That is the reaction normal. Perpendicularly to the surface. Clear, everybody? All of you? Ma, if it is the plane, remember, if it is the plane, the normal reaction will be like this. As it is inclined surface, still that it will be acting perpendicularly only, like this only. Do you all clear, everybody? All of you understanding?
Yes, sir.
Yeah, that is what you should remember. Now, let me draw for this one free body diagram. Of course, the body will start moving downward direction. That is what, let me take, this is x-axis. And of course, there will be perpendicular. So perpendicularly to this one, that is what we used to call as y-axis. So all of you remember, if it is a perpendicular means what is the angle always between them? Anybody can tell? This is x-axis and this is
90.
y-axis. What is the angle? 90 degrees. Is it clear?
90.
Yes. Respond, Ra. Others?
Yes, sir.
Yes. Now, if you notice it, so in between them, so this is y-axis and this is x-axis. In between them, something is acting downward direction. What is that called as? We used to call, here mentioned it, which is equals to what?
Weight.
So weight is equals to mg. Now remember, I will consider the angle between them is theta. And normal reaction is acting opposite to that. This is what n. Now, if you notice it, now I am introducing a concept called as how to find the theta. So whenever the weight is acting inclined to the surfaces, all of you can remember, so the resultant force is acting inclined to the surfaces. So this is what like weight. So weight is equals to mg, acting inclined surfaces. Now, if the theta will come here, if I take theta is here, this component will turns into mg cos theta and opposite one will turns into mg sin theta. Is it okay, guys? The force in y-axis and the force in x-axis. Clear? Understand? If suppose I take the resultant force like this, now if I make it two components, this is y components and this is x component, and here is the theta is coming. All of you observe, here theta is coming, then the force is equals to mg. Then here what will happen? Mg cos theta will come and here mg sin theta will come. Is it clear on what I'm saying? Wherever theta will comes, that is mg cos theta, and opposite one will turns into what? mg mg sin theta. So the force is acting two directions. All of you remember, if it is a plane surface, the force is acting only in how many directions? All of you? One direction. Okay. So the perpendicularly, it is acting, normal reaction is acting upward direction. Clear? Now, if it is the inclined surfaces, always the body is experiencing two different directions, because if it is sliding, all of you remember, if it is sliding, at every point it is experiencing a force called as downward direction. What is the force we used to call as, which is equals to what? mg, and it is also, it is moving sliding, so that towards to the x direction. So the force is exerting two different directions. That is why it is called as 2D, two-dimensional. So the force is always exerting on two different directions when it is in what motion? Inclined motion. Understand, all of you? So between them, the force which is exerting, that is what we used to call as resultant force. Always remember, if any object is moving in a plane, So always the force is exerting two different directions. One is y direction, another one is x direction. So the resultant force will act. The resultant force will act always between them. That is what R we is to call. Okay, Mari. If
The
suppose
resultant
here,
force is the downward force, sir.
resultant force will act always between the two directions. This is a two-dimensional motion. Clear, everybody now, Mr. Lingesh, Nivedan?
Yes, sir. Resultant force means it's a downward force, sir.
No, Mari, it will act always between two. For example, see, your body is moving like this direction and like this direction. Now, the resultant force will act between them like this. Clear? For
Yes, sir.
example, your
I'm
body is
asking
moving,
about,
yes, your
what
body is
is
moving
meant by
like this direction. Now you see that your body is moving like this direction and like this direction. Then your resultant force will act like this. Is it okay, everybody? Clear? All of you? Please respond, Amma. Girls. So now, if suppose if I mention theta is here, angle is here with the surface, then this will turns into, what will happen? R cos theta, and this will turns into what? All of you, R sin theta. Okay. If suppose if I mention a theta is here, then you tell me y-axis. Here what will happen? This will become R cos theta. And here it will become what?
R sin
sin theta. So that is you should remember. So whenever two-dimensional motion, the force is exerting always in two different directions. One is x-axis and another one is what? Y-axis. And the resultant force always acts between them. Resultant force always act between x-axis and y-axis. That is what you should remember. So if you take the inclined surface, now always we know that weight of the object is acting downward direction. So perpendicularly to that, normal reaction is acting. So that now the force is splitting. Actually, this weight is actually like a resultant force. So now two components, x component and y component. So x component I'm taking here as a theta. Then here what will happen? Anybody can tell me? What is this y-axis will come? Mg, respond. Mg cos theta. And x-axis what will happen? Mg sin theta. Now from this one, can anybody tell me? One along the plane. What is the force acting here? You can notice it. When a block is placed in a smooth inclined plane, all of you remember, inclined surface with angle theta. Inclined surface with angle theta. Okay. So the horizontal, the force acting in the block is force due to the gravity, which is acting vertically downwards. Then this force has two components. What is the two components? If it is inclined surface, if the force which is due to the gravity is acting downwards, then that force is having two components because it is a two-dimensional motion. So one is mg cos theta and another one is what? Two components. Another one is mg sin theta. Everybody clear?
Yeah.
Mg sin theta. Understand, Amma? All of you?
Sir.
Yes, if you want, you can draw the FBD. FBD means free body diagram. What is to call? FBD means, all of you? Free body diagram.
One doubt, sir.
Yes, Mani.
Body diagram.
Sir, you have written R cos theta, no, sir. It means it is result that is normal force, sir.
No,
Is it a normal?
this R means resultant force, Mari. Be very careful.
No, sir. I'm asking R cos theta.
R cos theta means suppose this force is, for example, I'll say 5 newtons. Then this is 5 sin theta. Clear? And here this is 5 cos theta. Clear?
Yes, sir.
That value. Understand, Mari?
Yes, sir.
Now that is what.
Sir,
Yes.
then we are using it as mg. Weight is equal to mg.
Yes, then
We
if
can
it
use-
is mg means resultant force, then here what will happen? Mg sin theta, and here what will happen? Mg cos theta will come. Clear?
Yes, sir.
Yeah.
They gave a value for the R.
Yes.
That is mg.
This R is not normal reaction. All of you remember that. That is what I'm saying. Don't get confused. This R means resultant force. Before the R, what we used is what? This is what actually. This R is normal reaction. Clear, Amma? So that is why better confusion. Avoid R and put what? Normal reaction, you put what? Everybody? N.
Yeah.
So N is the preferred letter in entire 11th class also. So use N so that it is no confusion will come. Now draw the free body diagram and you tell me this alone you imagine and you draw the free body diagram. So how the body will come. So the body is acting. So there is x-axis. What is the force acting x-axis? Mg Respond all of you. mg sine theta. Am I right, all of you? Nobody responds.
Yes, sir.
mg sine theta is acting x-axis. Is it correct or not? And
Yes.
y-axis perpendicularly to that. What is acting? mg cos theta.
Cos theta.
And opposite to that, there is a force which is acting. Normal reaction, and weight of the body, resultant force acting between them. What is that? W is equals to
mg.
W is equals to mg, and here will be the theta. So this is the FBD. FBD means free body diagram. Free body diagram. Okay, guys. Now, the force which is acting along the plane. What is that, guys? First one, you should identify. One along the plane. What is that? Along the plane. The force which is acting along the plane. Respond. mg sine theta. Okay. Next, one perpendicularly to the plane. What is the one perpendicularly to the plane? One perpendicularly to the plane. Perpendicularly to the plane. The force which is acting perpendicularly to the plane. Check it, everybody. What is that? Which is equals to
mg cos theta.
mg cos theta. One along the plane, one is perpendicularly to the plane. Now, from this, can you tell me normal reaction is equals to, what is the formula will come? N is equals to, check it, everybody, opposite. What is there? N is equals to mg or mg cos theta?
mg cos theta.
mg cos theta. So normal reaction is equals to mg cos theta. So that is what? Now,
In an inclined surface, sir.
yeah, inclined surfaces. If it is a plane surface, n is equals to mg. If it is inclined surfaces, n is equals to mg cos theta. Now, if I say the body is in rest, so means in the sense of the resultant force will become what? Yes, please. The net resultant, n is equals to mg. The body is not moving. The body is not sliding. So means in the sense of n minus mg cos theta must be equals to what? N minus mg cos theta, which is equals to what, guys? 0. Understanding? So that is what. So if it is an inclined surface, normal reaction is not mg. What is normal reaction? N is equals to mg
cos theta.
mg cos theta. And if the body is suppose moving, so these forces are always equal. So the body will never go upward and body will never come downwards. The body started sliding. So what velocity it is sliding? If I want to find that force, then that force, force in x direction. What is that? Force in x direction is equals to what? mg
Sin theta.
mg sin theta. So that is what you have to remember. Is it okay, guys? Everybody clear? Yes? All of you?
Sir, how can we find mg cos theta and sin theta?
We can
sir?
find, Mari. I will teach you. Next, that is what? Values I will teach you. You need to know cos theta. Theta value is, if you know, then you can start finding it. That is what? We will learn it. I will teach you. mg cos theta, mg sin theta, everything will I teach. Do you all understand now? If it is a plane surface, what is the normal reaction formula? Everybody? If it is a plane surface, the normal reaction is equals to what? mg. And if it is an inclined surface, all of you remember, weight always has how many components? You should speak, then only I can. If it is inclined surface, weight is always having two components. One is x component, another one is what component? Everybody. Another one is y component. So x component is mg sin theta and y component is what? mg
Cos theta.
mg cos theta. Always you should remember that. So if it is inclined surfaces, n is equals to what, guys? N is equals to mg cos theta. mg cos theta. Clear? That is what. Now, normal reaction under the action of an applied force. Let us check it now, all of you. So observe very carefully. Keep hitting. Next one. Normal reaction. Normal reaction under the action of an applied force. Applied force means in the sense of there is external force or not. Everybody read this statement. All of you should read.
Yes, sir.
Girls, any doubt, please ask me. Arasini, Abhirami, understand? So what is this? What is this meaning of this statement? They're asking normal reaction under the action of an applied force. So if I apply the force, then what is the normal reaction? Means there is applied force, external force. Am I right or wrong, everybody? Yes, please. All of you. Respond.
Yes, sir.
Yes. Now, Let us consider for this purpose, all of you consider, make it everyone. So case 1, let me take it into 2 cases. Case 1, all of you write it neatly. So there is a block, I am taking you. So let me consider the block. This is the block. Okay. So we all knows that weight of the block is acting what direction? Fastly. Weight of the block is acting what
Perpendicular.
direction?
Straight.
Downward direction.
Downwards.
So then upward direction something is acting. What is that actually? Normal. Okay. So we have to find it. What is that normal? That is what is our target now. But here there is a force, we are applying it. Am I right or wrong? All of you? Yes. So consider a block of wood or something is placed on a horizontal surface. Let the block is pulled by a force P. So it is pulling by a force P. Pulling by a force P like this angle. Is it okay, Mari? Clear? All of you?
In the backwards direction.
Listen very carefully now. I will teach you. Not backward direction, Mari. Pulling, Ra. This is pulling. Means a person is standing here and it is trying to pull this block over the surface. Clear?
That only, sir. He is standing behind it. So
Yes.
that he will.
Understanding? Everybody understand or not, Amma?
Yes, sir.
Yes. So now if you notice it, this person is pulling. It is not actually parallel to the surface. If he pulls like this, then you can see N is equals to mg only. All of you remember there is an object which is surface. Now let me take Mr. Kishore for example. He is applying the force like this. Applied. F applied. All of you write it. AP means what? Applied force. AP means applied force. He is pulling the object over the surface. Then weight of the object will act what direction? Everybody? Weight of the object will act what direction? Downward direction. And there is a normal force which is acting upward direction. So in this, normal is equals to what? N is equals to mg. Am I right or wrong?
Sir.
Equals to
Right.
what? Mg remains constant. Now, here the force is applied inclined to the surface with a theta angle. It is not normally applied. It is applied what? With the inclination. Is it clear, everybody? All of you? Respond, Ra.
Yes, sir.
Yes. So if it is applied inclined means you can notice it, all of you. So if it is inclined means just now I said it will be splitting into the what? Force will be splitting into the how many components? It will be splitting into the how many components?
Two dimension, two.
So with the surface it is making a theta angle, for example. Then here what will happen? You should speak here. P cos theta and opposite one here what will happen? P
Sin theta.
sin theta. Okay. P sin theta. Understand all of you? So now if you notice it, if I draw the FBD means what, guys? All of you? What do you mean by
Free body
FBD?
diagram.
Free body diagram. Imagine this entire block is like a dot of mass. So there is a two forces are acting upward direction. One is normal, another one is what? P sin theta. And downward, there is a force which is acting. What is that? Which is equals to mg. Which is equals to what? All of you?
mg.
mg. So means this forces is equals to this. Both are same direction. Addition or subtraction? Both are same direction. Addition or subtraction? Addition. So n plus p sin theta, which is equals to mg. We want only n. So n is equals to what will happen? mg minus p sin theta. Do you all understand, everybody? N means what? Normal reaction. Agalya, Purima Agalya, Shivani. Please
Yes, sir.
respond, Ra.
Yes, sir.
Everybody? Mari, understood?
Sir, one doubt, sir.
Respond.
First of all, we need to find the backward direction only, no, sir. Then why you are finding the value for normal force, sir?
Mari, our question is to find the normal reaction under the action of an applied force. Do you understand?
Yes, sir. Sorry.
Clear?
sir.
Are you clear?
Yes, sir. Yes, sir.
Everybody clear, Amma? Understood, Amma?
Sir.
That is what. So this is a case of what? Pulling up, pushing up. This is
Pulling.
a case of? This is a
Pulling.
case of what? Pulling. Okay. Now, the case number 2, pushing. Case number 2, pushing. So we all people know first, you can see motion chapter I have taught you. If it is the uniform motion, for example, here is the theta means, here also how much is the angle? Here also what is that? Theta remains what? Constant. Am I right or wrong? Agalya, remember da? Everybody.
Yes, sir.
Theta is remains constant at every level. So just keep this point in mind. Now, there is a block. All of you observe. There is a block now. So some person is applying the pushing up, pulling up. Now you see that I am applying the force. This is pushing up, pulling up.
Pushing.
Pushing. This is the push. Now we want to find what is the normal reaction. N. And always we know that weight of the object is acting what direction? Weight of the object is acting what direction?
Downwards.
Downward direction. Let me take what is mg. Now, if it is the pushing, all of you observe, the force is applied in this direction. The force is applied in this direction. So have you all noticed it? At everywhere, suppose if you make with the surface at theta, angle is theta means at every point the angle is theta only. Am I right or wrong, guys? All of you?
Sir, on the both cases, it is not pushing or pulling perpendicular. That is in a straight manner, no, sir.
No, Mari, this is pulling. Pulling is different. Pulling means see that P sin theta, that y-axis is acting upward direction and
Yes, sir.
x-axis is
Sir,
acting.
yes, sir.
But this is a
They
pushing
are
case.
not pulling or pushing it in a straight manner. In an inclined manner, they are pushing or pulling it, sir.
Yes, Mari, inclined. If it is a straight manner, n is equals to mg. I already taught you now.
Yes, sir.
If it is a straight manner, nothing is there. N is equals to mg. Force is acting only along the surface. Clear?
Yes, sir.
That is. Now it is a pushing case. So everywhere theta is same. You have studied in mathematics, inclined surfaces. If here is the angle theta, then here is also what is the angle? Everybody. Perpendicularly
Theta.
opposite angles, theta only, correct? So the force is acting now, pushing force. If the pushing force means the force is actually acting in this direction. This is what